Dear students, today we are going to learn database management system and its application in libraries. So we are talking about data models, DBMS, then how DBMS progressed into RDBMS, that is Relational Database Management System, and how libraries are depending on database management system. For example, if you take a serious look in your library, everything is database. For example, your accession register. There are generally 14 columns. Don't you think those columns are fields and a filled up row like accession number, title of the book, author of the book, price of the book? These are all a kind of a row, completed row, and thereby it's a record. So accession register is a record. Your catalog, card catalog system is again an example of database system. For example, your cabinet, entire card system is a database. Then every card in it is a record. Then within the card, you are writing different kind of bibliographic data elements. Those are basically, attributes of the entity book. And in this way, this field compiles into records, a set of logically related records converted into a database, and the software which handles, this record files, databases is called database management system. And it is not necessary that every time you need a DBMS. Even in a manual system, you are also managing a database. For example, your friend list in your phone, or you are maintaining a telephone directory. That is also a database. A class teacher is making roll call and filling up his or her attendance sheet. That attendance sheet is also a database. So it's not necessary that every time you are using a software to manage data. We are all managing data every time, and the collection of related data is called database. And when you are applying a software to handle all of this, like your inserting new data, updating existing data, retrieval of the entered data, then it is called a database management system. So let's get ready. We are going to make a in-depth study of this particular domain. So here the title what we are talking about is data models, DBMS, generic and bibliographic, because generic databases, the requirement is slightly different. And when you are talking about the catalog database or different kind of bibliographic database, your member database, their requirement is something different. So we need to understand that particular differences. Okay, so what are the basic concept of database management system, or popularly we call it DBMS? When you are talking about DBMS, that is a system that manages databases or data sets. And there are two clear-cut visible main components of this system. One is the database, like as I said, like your card catalog, the entire cabinet. It's a collection of related data. Here, a collection of related cards. And that data is managed by a system which is called management system, which is responsible for the, sorting of your catalog card, retrieving of your catalog card, how you are managing different, or adhering to different kind of rules and principles in handling that catalog data sets and so on. So this is equally applicable to all other domains of life, like a railway system. They are managing huge data, train related data, passenger related data, reservation related data. Same is the case with business, airlines, university system. They also manage different kind of data sets, student data set, faculty data sets, salary data sets, and so on. And many of you possibly using Excel or spreadsheet, open office LibreOffice, MS Office. So they include one spreadsheet like MS Excel, OpenOffice Calc, etc. Those are also a kind of data set, because here there also you are managing different kind of columns and rows. So with this brief introduction about database management system, if we go further, if we go into further details, then what is a database basically, and what is a data? A data is basically a raw facts, and the meaning of data always comes through its metadata. For example, if I say 175, does that mean anything to you? If I say 175 centimeter, then you are in a position to understand, okay, teacher is saying something about length, and that length may belong to anything. It can be a length of a table, length of a chair, various other objects. But if I say that average height of NSOU BLIS class is equal to 175 centimeter, then the complete meaning actually carries to you. You understand what that data mean. So what I have added, a label to the data, that is the metadata. And in that case, generally in colloquial term, we call those metadata as fields, or in technical term, we call them attributes. Attributes are the most essential properties of a given entity. Like say, for example, student is an entity. So the major attributes is the name of the student, date of birth, roll number, enrollment number, course of study, and so on. So in this way, we collect data. We then organize those data into records. Records are basically set of logically related fields. Then different records we gather inside tables, and lot of related tables we call it a data set or database. So it's very easy to understand now that data is the unit or a block unit of the given system of database management system. Then we also need hardware to store that particular data. We need software to handle that data set efficiently and meaningfully. We need users. There may be two kinds of user: administrator of the database and end user of that data set. And there may be different kind of privileges. That means the authentication level. Say for example, in your library, the entire super user password of a library management system is held with the librarian. Then cataloging staff is having also login and password, but they have restricted to the catalog dataset only. Circulation staff are restricted to or having privilege to deal with only circulation data, but not the entire modules of the library management system. That means what you are restricting? You are basically restricting a user on the access of different kind of tables, different kind of data sets. So this is called privilege control in the context of the user management. And then you have a lot of procedure: how to insert data, how to standardize data, how to retrieve data, what should be the query language. That query language we generally call SQL, structured query language, and so on. So these are all the basic concept related with this one. And in the screen you can say I have given an example of a very small simple kind of data table. So here we have four students with four different roll numbers, 1 through 4. Then they are having name A, B, D, and so on, and their age. So here you can see role, name, age are basically fields or column name. Then every completed row is a tuple or a complete record. So all kind of these records of a student data set is called a database. And the database management system is handling how can you enter data, how can you modify data, how can you delete data in case of necessity, and how can you create this data set, how to alter, draw, different other operations related with a database. So that is the role of a DBMS. Now here again in the screen you can see I have given four tables here. You can see these are called atomic table. So everything we have not jumbled in a single table. Rather we divided this this entire data into four table. Table 1 includes the role as a primary key of a student, and student name and age is given just like the previous example. Table 2 includes the address of that student. Role 1 belongs to Kollani, role 2 belongs to Barashat, and so on. Table 3 includes that against roll number, which is a primary key, that which students is studying in which year, second, first, third, and so on. And then table 4 indicates that which particular year of students, a second year student, are staying in the hostel H2, first year students staying in the hostel H1, and so on. So now if I make a complex query, like which hostel does the youngest student live in? So this question requires all the three tables, T1, T3, and T4. So from table 1, it will select that by comparing the age, that which one is the youngest student among these four students. Then it will find its roll number 1. So from table 3, it will get roll number 1 is belonging to the second year. And from the table 4, it will get that the second year students are staying in the hostel H2. So this is called joining of tables, union of tables. So a very complex question like this, many of the tables are required, and there are relationship between this table. Everywhere you can see roll number is holding the key in case of table 1, table 2, and table 3. And for table 2, the primary key is year. So it can match in this way to give you answer to a complex question. And there lies the relationship between the table. And that's why database management system, initially it was not supportive towards relations. Those every tables are individual in nature. We cannot join, we cannot make union. Nowadays, with the progress of computer science in the late 80s, this relational data modeling came, relational database management system came, where we can integrate different data tables against a query, and relationship could be established amongst all of these data sets. So there are basically, when you are trying to achieve that kind of complexity, there are basically three steps that we need to follow. First we need to select an entity on which you are going to collect data. So for example, in case of a library, books can be an entity, your members can be an entity, different kind of acquisition system, again the book can be an entity. So we have to select the entity. Then you are going to find out that what are the required data elements, say bibliographic data elements for cataloging and bibliographic data elements for acquisition may not be the same. Definitely there will be some low overlap, something, some common elements will be there, but exactly it won't be same, because the creation of database is depending on a very specific purpose. What you want to achieve? You want to achieve efficiency in acquisition. Your data requirement will be different. There, ISBN is a very important thing. Publisher is a very important thing. Vendor is a very important thing. But do you think that vendor is an important element for cataloging also? Not at all. But ISBN and publisher are still valid in bibliographic data description. So that depends on the purpose, and the basic step is first you collect data, organize that data into tables, those are called records, and finally that records you need to achieve different kind of atomic tables, and you need to establish relationship between those tables. So these are the three fundamental steps related to it, managing a database management system. And here in the screen, you can see the relationship between the database and database management system. There are different layers. So at the core of the core, your collected data, that is database. Database are actually a collection of related tables. You are organizing your data into various tables. Tables includes a lot of column or attributes. Those are the essential properties of an entity. For example, here you need to give a strict yardstick. For example, as a student, your date of birth is an entity, your enrollment is an entity, your course of study is an entity, is an attribute. But what about your color of your shirt? This is also, suppose you today in the class with white shirt. So is that a property? Is that an attribute to describe you? Because this is not, because your shirt, color of your shirt is not permanent. Next day you may wear a different colored shirt. So the permanent and essential properties that can describe you as a student, those only be considered as attributes, like your name, your date of birth, your enrollment number, your course of study, your fees payment, and everything. So that is the definition of attributes. Then when you are filling up almost all the given attributes of a student or an entity like a book, you are getting a set of records, and that record, attribute, table and database, entire thing is managed by the database management system. It handles how to insert data, how to modify data, how to delete data, how to define data sets, that what column should be going, what should be the property of each attribute, and so on. So this is basically the relation between the database and a database management system. And database management system nowadays omnipresent in the society. You go anywhere, you will find a terminal, and that basically a terminal or computer is handling data sets in different format. For example, even in an operating system like MS-DOS or Windows or different Linux-based operating system, we are handling different folder includes subfolders is having file, we are copying one file from another one folder to another folder. These are all basically primitive level of database management system, but still a database management system where operating system follows a hierarchical order. That is the root, then comes the folder, then under the folder a subfolder include files and so on. So here you can see, as it is omnipresent, you go anywhere like banking industry, different kind of airlines, railways, telecommunication, manufacturing unit, supply chain management, etc. University system, everywhere they are present. And as I said in the initial statement, that a library is basically a collection of databases. And a librarian is basically a database manager. When you are managing your accession register, your card catalog, your library automation database, your digital library database, everywhere you are managing basically databases. And different kind of retrieval comes to support or to ensure the efficiency of that kind of data set. So if we move to the next slide, that is everything is rosy in case of database management system. There are many, facilities, many advantages, but we need to be very careful for some of the, downside also. So in the upside or advantage side, we can manage data redundancy, that is to avoid data duplication. Storage efficiency, huge number of data we can put together inside the storage system like hard disks and so on. Data consistency we can achieve. We can provide multiple users, to access that data set from different places at different point of times. So the moment you are making your database accessible over the web, it became time independent and place independent, two fundamental barriers to information communication. So data sharing is a very, important aspect of database management system. Apart from that, we are having advantage like data integrity, and then achieving reliability, that at the time of need we will query the database and database will give me the correct answer. But at the downside also, the moment you are managing a database, lot of other responsibilities coming to you. Say for example, protection. Every now and then you are hearing in newspaper that the entire Aadhaar data set of a given community has been leaked inside internet. Your health insurance data has been leaked inside internet. So there actually the authority failed to protect our data. So that needs to be ensured that your data must be safe and secure. Second is the access control or privilege control. You need to be very cautious about who can access what kind of table. And in that way, you can protect your data set. For example, there should be only one user, like a super user for your library system, who will be having the super user password of your library management system. Rest of the other people will be having limited privileges like catalog stuff, circulation stuff, and so on. And data security is a very important thing. We'll be coming to that. So these are the pros and cons of a database management system. And a rate symbol actually here, the red line I have given in the slide, it basically indicates that where you need to be very cautious when you are managing a database management system. So altogether, if we talk about that how libraries are related with these DBMS, I have given lots of example where We can consider library as a collection of database and librarian as a manager of those databases. But if we go in a pinpointed way, then we can apply that to organize our resources in the form of cataloging, in the form of indexing, and so on. Then data retrieval, that's a very important part because your library is present there. You are managing database to support end user information retrieval so that people can find how many books are there by a given author on a given subject, whether this particular book is available or not, how many copies are available, which copy is available for circulation, and so on. So all of this data retrieval part is handled by your database management system, of course, with some kind of front-end arrangement where people can search. General people, you can't expect that they will make an SQL query to get the data. They will simply type their keyword-based search or field-based search that the field is title and whether the title includes that phrase or not. So this particular part is called end user retrieval, very important aspect of database management system everywhere and more so in case of a library. Then you need to go for the patron management, how new members are coming, how you are managing your staff, then inventory control or acquisition, reporting and analytics at the end of the day, how many books are issued in a given day, in a given period of time, what are the budgetary position, how many amount of money you actually spend to acquire book on a given point of time. So all of this can be answered in real time, and that particular system is called reporting analytics, and altogether that leads to MIS, management information system, where in real time we can get different kind of predefined statistics or custom defined statistics or report we can generate from backend database management system. So if we now go that this database management system and library, let us take the example of library automation software. So a library or typical library automation software includes many modules like acquisition module, cataloging module, circulation module, OPAC, and you will be amazed to know that in the decade of 70s and 80s, there was a piecemeal approach of library automation because there was no concept of relational database management system. Now in the late 80s, early 90s, we have got the concept of relational database management system. A lot of such product came, open source product like MySQL, MariaDB, PostgreSQL, and library automation software started using those RDBMS at the back end. Here you can see you have many modules, but a single database. So every time you are doing an operation in cataloging, in acquisition, in circulation, in interlibrary loan, in report generation, everywhere it is going or coming from your central relational database management system. So that is the beauty of relational database management system, and that is the relationship a library and an RDBMS share. Every library software depends at the back end on some of the relational database management system, and most often we use open source relational database management system like MySQL, like MariaDB, for example, Koha, the most famous open source library management system that uses MariaDB or MySQL at the backend. Similarly, DSpace, a very a renowned digital library management system, is using PostgreSQL as at the backend. SQL here you can find as a common phrase because these are all based on a standard called SQL 99, and that's why these are called SQL. So now you can see that, as I said, that every known library software like Koha, DSpace, here you can see ViewFind, the library discovery system. Every software has a relational database management system at the back end, as I said, and most of the LAMP-based package in the LAMP architecture, AIM stands for MySQL or MariaDB. But many software can also use a more structured and scalable open source RDBMS like PostgreSQL and so on. So if we now go for components of database management system, here you can see every database management system, be it closed source product like Oracle, Sybase, MS SQL, or an open source product like MySQL, MariaDB, PostgreSQL. As I said, these are all based on the same common standard called SQL 99. So all of these can be divided into three basic compartments. And Those are called three basic components of a database management system. First, you are creating a data set, like how to create a particular, data structure, then how to modify it, how to alter it, how to drop it in case of necessary. So these are called data definition language. Now, when your data structure is ready, you are all set to enter records. So you need to insert data, you need to edit data, you need to delete data sometime. So these are called data manipulation language. Every database management supports these three components. And the final component is data retrieval language, where you are allowing to access different kind of data. As I have given example earlier, that in which particular hostel the youngest student lives in. So in that kind of complex statement, say for example, you want all the books written by S.R. Ranganathan, published by Asia Publishing House, and published during 1957 to 1967. So this kind of complex queries required to handle and join or union of different kind of tables in real time, and that is basically called data retrieval language. And there the some of the common keywords or commands are select, where, order by, and so on. So these three are the three basic components. You are defining the data definition language, you are managing insertion, addition, deletion, modification of data manipulation language, and finally retrieval. You can browse it or you can search it. So again, when you are creating different kind of databases, as I said that you are finally managing your data set through tables. So you need to follow some kind of model, and there are right from the 70s, with the advent of personal computer, there were different kind of models. As I said, that operating system is also in a crude way a database management system, because it is managing a lot of folders, subfolders, and files. But the model is hierarchical. So how many models are there? You need to understand the data model behind DBMS. So it can be different kind, but we are interested in record-based data model. And record-based data model can again be divided into three parts: hierarchical model, like operating system; network model, like our age-old CDSIS, software, or WinISIS software is based on network model. And the latest one in this series is relational model. And this data set, you can see the hierarchical model follows a tree structure. Network model, it basically manages different kind of blocks, different kind of file to file relationship. And relational model are based on tables, columns, and rows, and they establish relationship between these tables, and finally they achieve normalization to achieve acid property. Acid property will be coming very soon, what it is. So this normalization is also required for relational data modeling. And another one in the pipeline is object-oriented model. But in the bibliographic domain, there is no instance of object-oriented model yet. So we will be restricting our talk to this RDBMS, or relational data modeling. Now, if you come that what is the difference between a simple DBMS and an RDBMS? So here you can see in the slide that in case of a typical DBMS, we handle files. In case of RDBMS, we handle tables. And in case of DBMS, there is no relationship. It provides only basic security and supports only a single user at any given point of time. On the other hand, RDBMS supports relationship establishment, security is at the advanced level, and multiple users are supported. And this is the differences. How we actually discussed is that how a simple DBMS is different from an RDBMS, or rather on the other way around, that how an RDBMS is an advanced level product in compare with a simple DBMS. Three things you please remember. Data available in a tabular format in case of RDBMS, and they achieve this ACID property: atomicity, consistency, isolation, and durability. Very important component related to an RDBMS, which is not available in case of DBMS. And apart from that, it supports also relationship. So here you can see most of the RDBMS are based on ER data modeling. ER data modeling, expert says that in this world, there are entities. Entities had their attributes, and two entities are related with each other. So there are only a trinity of database management system. You identify entity, you identify attributes or important properties of that entity, and establish relationship between two different entities. So in case of a bibliographic domain, suppose this entity one is a book, it has got different attributes like title of the book, subject of the book, author of the book. So these are the two books, and you can see what is the relationship between the same book of edition 1 and edition 2 of the same book. So this relationship you can establish, or this is the original document entity 1 and this is the translation of that original document. So how we can establish relationship? So this is basically the trinity, we call the trinity of system. And entities can be of two types, strong entity and weak entity. Suppose I am going to design a database on my employees at my universities. So employee here is a strong entity, but the dependent of that entity, like his or her parent name, children name, spouse name, these are called weak entities, which are actually depending on the strong entity, here employees. So in this way, attributes can also be of different type, key attributes, composite attributes, and so on. And as a database manager, we need to understand this entity, attributes, and relationship between these three entities. Even as a librarian, when you are doing a lot of cataloging and other tasks, your catalog is a database management system. So there are a lot of models are available like FRPR, FRAD, FRSAD. All these three integrated into LRA. We have a model called BibFrame 2.0 from Library of Congress. The FRBR group is from IFLA. All are actually based on ER data modeling. So this is a very important thing to understand, that what is the role of data modeling in the data set, how you can identify entities, how can you identify or determine important properties like attributes, you establish relationship, then on the top of this you design a database schema, normalize that schema, and finally you are able to query that particular data set. So here again you are getting a new term which we have not discussed so far, normalization. So normalization is a very important thing of a database management system. But before that, we need to understand why normalization is required for data modeling. So in this example, what I have given, so rectangle represent entities, ellipses represent attributes, diamond shape represents relationship, and lines represent the kind of relationship is here. So here you see, I want to draw here how three entities, student, department, or four entities rather, lecturer, and course are related with each other. So here you can see student enrolls in course. Course is offered by department. Department employs teacher. Teacher teaches to module. Module is included in course. In this way, three entities are related in multiple dimensions. And in the right hand side, you can see student as an entity. What are the important attributes like given name, surname, student ID, of which one is the primary key, which is the student ID. Similarly, in case of a book in your library, accession number is a primary key. And here how student is related to a given course. So in this is called an data modeling, entity relationship diagram establishment, so that we can visualize the relationship between different entities, and accordingly we can design our database schema. So here comes the normalization. Normalization is an important process which helps to improve our database schema to ensure efficiency, consistency, and accuracy. And there are different kind of normalization, different advantages of normalization, how to define a data set, to establish the purpose of managing that data set, applicable methods to design the schema, how to avoid different kind of anomalies like insertion anomaly, deletion anomaly, or updation anomaly, and so on. Here I am going to give you one example which basically make things clear to you. So here in the first case, you can see I have given a unnormalized table where employees, their IDs, their department, and etc. available. Here you can notice that there is a data redundancy. HR came twice, HR as a department, and London also came twice because two employees of this database belong to HR department, and we have repeated that's why HR and London twice. So this is called data redundancy, and this is unnormalized table. Now, this kind of table can create a lot of anomalies. Suppose one particular, there is a single employee in the IT department. The moment he or she left, the entire row is lost because we have selected that employee as our primary key, an employee ID and employee name, on which department is a transitive dependency. So the moment I delete this employee as they left this department, so the entire row is missing. To avoid that kind of insertion anomaly, updation anomaly, and so on, like if I want to suppose HR department change its place from London to Paris, so again I need do that particular editing twice. So after normalization, when we apply this acid property, anomaly detection and other things, we convert that table into its to achieve atomicity. Here you can see I can now divide this table into three structure and three unit table. One is employee table, second is the department table, third is the employee skill table. So in this way we can achieve normalization, and there are different forms of normalization. First normal form to achieve atomicity, second normal form to achieve or to reduce partial dependency, third normal form to reduce transitive dependency, and fourth normal form or BCNF, there should not be any kind of multi-valued duplication. So normally in the bibliographic word, third normal form is quite sufficient. And here, after achieving this relational data modeling system, applying normalization, then there comes the CORD rules. CORD rule says you that whether your database management system, whether your design and schema is RDBMS, relational data model or not. So there are 12 rules. CORD is considered as the father of relational data modeling and relational database management system. He has given these 12 rules to check the compatibility of a database management system with its relational nature, or in simple words, whether you can call a DBMS, RDBMS or not. So in summary, this particular CORDS rule, all 12 rules actually talks about that data must be represented in tables, table must share their relationship, and every relationship should be based on the primary keys. So these are the few important things, and you please go through the CORD 12 rules to understand what it is. So how database is related with the library? Then you go, as I said, that everywhere you go, you have database management system. In the library world, the entire databases systems can be divided into two groups. Either it's a source database or it's a reference database. For example, your catalog is a reference database from where you are basically directing your users to the book. On the top of this call number. Call number is a tag, nothing else. And there are source database like full text database and so on. So in one go, there are different kind of database: bibliographic database, catalog database, multimedia database, but they either belong to the source category or the reference category. And in the form wise, they can be CD-ROM based, they can be online and so on. Or online can be again two types, that direct access online or web enabled online. So everywhere there is data set, and normally in case of cataloging, it is very visible. In the catalog, we use different kind of content designation like UK mark, CAN mark, CCF, Mark 21 to form the database schema. Then to enter data, we use different kind of cataloging rules and tools like ASCR2 as a catalog code, ISBD as a standard bibliographic description, and so on. And at the physical level, we have a standard for data sharing, data export import, that is called ISO 2709, which is again based on an ANSYS standard called Z39.2. So in a nutshell, you can see that in a library world, we first collect data about book, then enter in a worksheet, then by on the basis of that worksheet, we enter data, we store that in a database management system. As I said, most of the cases library use relational database management system at the back end, and then our users and library professional or staff member can access that database. So ER data modeling has a great influence on library world. As I said, most of our new generation bibliographic data model like FRBR, FRAD, FRSAD, all are actually based on ER data modeling. These three integrated into LRM, library reference model, and these are all from IFLA. And as Library of Congress also came with an equally good data model, which is called BibFrame 2.0. So here in case of, if FRPR, you can see there are three groups of entity. Group 1 entities, it's basically work. Work is realized into manifest expression. Expression is embodied in manifestation, and manifestation is exemplified by an item. So what does it mean? Just imagine Gitanjali written by Rabindranath Tagore. So Gitanjali have a lot of translation, Bengali, English, Hindi, and so on. Each of these are expression. Let us take the Bengali Gitanjali. So Bengali Gitanjali finally published by Vishwabharat. So that's a manifestation. And that Bengali language based Gitanjali published by Vishwabharati, it has 500 copy. So each copy is an item. This actually called group 1 entities of this one, and based on relational database modeling. Here in this relation, you can see this is somewhere it is single arrow, somewhere it is double arrow. So single arrow means when you are saying from walks to expression, so one walk may have many expressions. That's why this one is to many relationship. But when you view from expression to walk, one expression may origin from one and only one walk. So here relationship is n is to 1. Here 1 is to n. So in this kind of relationship we have in bibliographic data model. In group 1 we have WEMI, work expression manifestation item. In group 2 we have person and corporate body. And here you can see how group 1 entities are related with group 2 entities. Similarly, in group 3 entities we have a concept of different kind of subject, concept, object, event, place. And these are also related with group 1 and group 2 entities, like the relationship is has as subject. This is the kind of BibFrame 2.0. The modification you can see, BibFrame sees that work and expression as work. Then manifestation is equivalent to instance, and item is item. So there are again different kind of agent, subject, and so on. So you can say BibFrame 2.0 is a kind of poor imitation of FRBR model. And here you can see a real life example. Suppose I have a copy of Harry Potter at Birbhum District Library. So that's an item. That item has common attributes or major attributes like item ID, barcode, or accession number. Then we catalog the manifestation. Manifestation has different, attributes. Mostly we follow ISBT or Mark 21 here. Mark 21 is also based on ISBT. So these are the important attributes like title, author, publisher, subject, and so on. So that item and manifestation is related to the expression. Here you can see expression. The Harry Potter, that book is English language, that is expression, and the work is related to the Harry Potter. And J.K. Rowling is the author, so how person is associated this one. So it's not a new thing. We are doing this thing right from the time of Anthony Paniji, but not in a structured manner. So FRBR, or which is the application of ER data modeling in bibliographic domain, that first gave us a theoretical backend, theoretical foot to establish that cataloging principle. And we have many other, related application. Like the moment we go for relationship, we can establish a relationship between an original work like Pather Pachali. Then adaptation by Satyajit Ray in the movie of Pather Pachali. Then abridged edition of Pather Pachali as Amatir Bhepu. So all this can be related with each other in real time through this RDBMS, and can be given a visual navigation aid to our users. And another important thing is coming in this domain is called NoSQL. So the whole world is moving from SQL to NoSQL. NoSQL means there will not be any field kind of thing, no structured, data set. everything will be available in textual format, and textual format will be encoded with different kind of XML, and that is very helpful for indexing of by the web search engine. For example, your library, every book data is available under RDBMS. You won't allow Google to index that database management system for security reasons. So if you make that available in a NoSQL mode, in an XML format or XHTML format, Google can easily index that and you do not have any kind of security threat. So the entire world is moving towards that NoSQL system and that follow document or key value pair, graph structure and so on. The best example I can give for NoSQL is the MongoDB that people are using, like, in case of full text database and so on. And finally, as a beginner of this database management system, it's a fascinating area of study. You can go through these fundamental books, including FRPR as originated from IPLA.